Good morning to everyone. I am Devesh Banerjee, lecturer of Electronics and Telecommunication Department. Today, I discuss the next topic, which is instantaneous sampling. Okay. So, the instantaneous sampling is also called ideal sampling. Ideal sampling. Okay. The instantaneous sampling is also called the ideal sampling or impulse sampling. Impulse sampling. Okay. So the instantaneous sampling is also called the ideal sampling or impulse sampling. So by the use of instantaneous sampling, we convert the continuous time signal into discrete time signal. By the method, which method is used for instantaneous sampling? This method is multiplication. Okay, multiplication method. Okay, what is multiplication method? Now here the two signal is xt, which called the baseband signal, and impulse signal, okay, which denoted by del ts. Okay, so the baseband signal is denoted by xt and impulse signal is denoted by del ts. These two signal are multiplied. Okay, these two signal are multiplied and output of the multiplication get the ideal sampling. Okay, get the ideal sampling. So these two signal are multiplied by each other and get the ideal sampling. So what is xt and what is del ts? xt means baseband signal, which is denoted by xt, which is this signal. Okay, this signal is xt, which is called the baseband signal. Okay, and next signal del ts, which is called the impulse signal. So okay, the 0, ts, 2 ts, 3 ts, and here minus ts, minus 2 ts, and minus 3 ts. Okay, so this is the impulse signal. And these two signal are multiplied each other. So here a multiplier is used. Multiplier. Okay, which multiply the xt and multiply del ts. Okay, and output is got the gt, which is called the instantaneous sampling or ideal sampling. So these two signal are multiplied by the multiplier and output is denoted by gt, which is the instantaneous sampling. So what is the figure of gt? This is the figure of gt. Okay, this is the xt and this is the del ts. So this is the figure of Okay, when when these two signals are multiplied by each other, we get the signal GT. Okay, this is the GT, which is the instantaneous sampling. Okay, this is the multiplier is multiplied by these two signal and get the GT, the figure of the GT shown here. So this called the instantaneous sampling. The width of the pulse, the width, here the width of the pulse, this is the width. Okay, so here the width of the pulse is denoted by tau. Width of the pulse, tau is the width of the pulse, width of the pulse, okay, which is 0. So the width of the pulse is 0, so tau width of the pulse is 0. This is the disadvantage of instantaneous sampling. This is the, because the width of the pulse is 0. If the width of the pulse is 0, the noise is more affected in this signal. Noise is more affected in this signal. So this is not used in practical method. This sampling technique is not used in practical method. This is the theoretical method. Okay, because the tau is 0 and this sampling technique is not used in practical method. This is called the instantaneous sampling, and the circuit diagram of the instantaneous sampling, which is called the multiplier, is shown here. So the circuit diagram of multiplier, okay, the circuit diagram of multiplier. This is the circuit diagram of multiplier. Okay, this is the circuit diagram. This is xt, and here the output is denoted by gt. Okay, here a switch is connected. Here a switch is connected. This called the switch S, and here del Ts is applied. Here xt is applied and here del Ts is applied, and get the GT, which is called the instantaneous sampling. Okay. Next we discuss the natural sampling. Okay. Natural sampling. The second method is the natural sampling technique. Here the working principle of natural sampling depends on chopping principle. Chopping principle. Okay, here a periodic pulse train is used. Okay, in instantaneous sampling the impulse signal is used, but here a periodic pulse train is used. Okay, so this is the chopping circuit. Chopping. Okay, this is the chopping circuit. Here we applied the xt, which is denoted by baseband signal, and here is applied the periodic pulse train, which is denoted by ct. Periodic pulse train is denoted by ct, and output of the chopping circuit is gt, which is the natural sampling. Okay, so which is xt? Xt is this signal is xt. Okay, this is the xt, which is called the baseband signal, or which is called the message signal. Okay, and ct, this is the pulse train. This is the pulse train. Okay, this is the 0 pulse train, and it is denoted by ct, which is a periodic pulse train. Okay, these two signal is applied to the chopping circuit, and output of the chopping circuit is a natural sampling. or natural sampling signal or natural sampling technique. So here we get the GT. Here we get the GT. So GT is, so the GT is, the figure of the GT is okay, this is the XT and figure of the GT is this, this type, this type, this type. This. It is the GT, which is the natural sampling signal or natural sampled signal. Okay. Here GT has the width. Width is denoted by tau. Here the tau is very small. In previous sampling, which is called the instantaneous sampling, the tau is 0. The width of the pulse is 0. But here the tau is very small compared to the instantaneous sampling. Okay. So this method is a practical method. Okay. This method, this technique or natural sampling is a practical method technique. Okay. The circuit diagram is same as instantaneous sampling. The circuit diagram is same as instantaneous sampling. This is the circuit diagram. Same. Here the applied XT. Okay. Here the XT is applied and here the output, which is GT. Okay. This is the GT and here a switch. Here XT is applied, here CT is applied, and we get the output GT. This is the natural sampling technique.